Good morning all. This is Swapna. Welcome to machine learning video. Today's our topic is Bayes optimal classifier. To understand this, here we are taking the simple example. With that example and with the formulas, we are going to explain about the Bayes optimal classifier. So in this example, there are three hypotheses are there with the probabilities of 0.4, 0.3, 0.3, etc. So within this, H1 is having the maximum probability. Then we can say it is a maximum a posterior hypothesis. To encounter the new instance X and H1 is to predict the new instance X, and within these probabilities, which one is the optimal classifier? Optimal hypothesis, optimal classifier. To understand that, for this new instance, H1 is classified as a positive and H2, H3 are classified as a negative. Taking all the hypothesis into account, the probability that X is positive for 0.4, and it is a little bit different from the maximum a posterior hypothesis. Within this example, with this probability, I said already H1 is having the maximum probability, then we can call it as a maximum a posterior hypothesis. But to find out the optimal classifier, there is another problem which is different from the map, and here we consider three hypothesis probabilities 0.4, 0.3, 0.3, and H2 and H3 are negative and H1 is considered as a positive to find out the optimal classifier. So, possible classification of the new instance is obtained by combining the predictions of all the hypotheses. How we are combining? Like this, we are combining by this formula. Any value Vj from the set V, complete total set is represented with the capital V, and particular value is represented with the Vj. So to find out the probability of that one with the correct classification for the new instance, Vj, to find out the correct classification, this is the formula we are using. Summation of every hypothesis belongs to the capital H hypothesis space, probability of V of j by Hi, probability of H of j over the training data. This is the new instance probability over the hypothesis. This is the probability of every hypothesis over the training data. By the summation of for all hypotheses, we will get the new instance correct classification. Whatever the new instance correct classification by this formula. And to get that optimal hypothesis, that formula is changed as like this. Bayes optimal classification within this, which with the summation of all the, to find out the classification of new instance by this formula, which is having the maximum value, that we can call as a Bayes optimal classification. To understand this, once again we are continuing with our example. So what are the example? We took three hypotheses and three probabilities. So what is the positive and negative values to are represented with these symbols, plus and minus. To represent the negative, minus to represent the positive, plus symbol is used. And three hypothesis probabilities are probability of H1 over the training data is 0.4, H2 over the training data is 0.3, H3 over the training data is 0.3, and this one is H1 probability of positivity is, already we said this H1 is positive, that's why probability of positive hypothesis 1 is represented 1 and negativity of this hypothesis 0, and H2 and H3 we can say in this example both are having the negative. Both are negative hypothesis. That's why probability of negative hypothesis of H2 is represented with the 1 and H3 is represented with the 1. Positivity of the H2 is 0, positivity of H3 is 0. To find out that, we used the formula of whatever the formula till now is so used to get the Bayes optimal classification. Within this two, we are applying for this all the hypothesis. For the positivity and for the negativity. For the positivity, 0.1 plus 0 plus 0. 0.1 into what is the probability of positivity? First we are taking this one, probability of hypothesis, that is 1, and probability of hypothesis 1 is 0.4, plus probability of positivity is 0 into 0.3. 0 into 0.3, then we will get the total of 0.4. So we are substituting these values for this within this formula also. For the negativity, it is for first hypothesis, negativity is 0. 0 into 0.4, so that is 0. And next 1 into 0.3 plus 1 into 0.3, what we are getting? 0.6. Within these two, which is having the optimal value or which is having the maximum value, that we can call as a optimal Bayes classifier. So 0.6, the negativity is having the maximum, then we can call this one is the optimal Bayes classification. So by this I am concluding this video. So Bayes optimal classification for this new instance is taking the weighted vote among all the members of version space. Each candidate hypothesis weighed by its posterior probability, and H space includes the hypothesis that perform the comparisons between the linear combinations of predictions of multiple hypotheses. We are concluding with these statements. We got the value of negative is having the highest probability. So by this I am concluding this video. This is about the Bayes optimal classification. For this, what is the formula we are using? This one. And to find out the probability of everything, this is the formula. Probability of what is the correct classification for the new instance is calculated by using this formula. In this, for every type of classification, which classification is having the maximum probability, maximum value, that we can call as a new instant classification. That's why we proved with this example. So this value, this probability of this classification is having the maximum for, so we can say this is the optimal classification for the new instance. This is the optimal classification for the new instance with this data. So I am concluding by this. We'll meet in the next video. Thank you.